Well, hello, pre-calculus students and seekers of truth especially. In this video, we will look at an example of parametric equation that doesn't involve motion. We've seen certainly lots of examples of parametric equations that use motion, free fall motion, and such. And let's take a look at parametrics in another context. So, at a local beach, the sales of sunscreen and ice cream for 5 different days are recorded below. That should not say 5 different days. Those are 4 different days are recorded below. Here's the table with some information. Find an equation that relates the temperature to the number of the sunscreen bottles. Find an equation that relates temperature to the units of ice cream. And finally, find an equation that relates the temperature of sunscreen bottles sold to the units of ice cream sold. Well, all right, so let us begin here by defining some variables. So temperature, I'm going to start out with defining using some variables. Temperature, we'll use F here to represent temperatures in Fahrenheit. Sunscreen, we'll use S. And then ice cream, we will use I. All right, now in part A, let's look at just these 2 columns. Let's look at temperature versus sunscreen bottles. And if you look at this pattern, we should probably create a scatter plot of this to get some better knowledge, better sense of this. But we can also try some things here because the numbers are relatively simple. 72 minus 67 is going to be 5. 73 minus 67 is going to be 6. 67 minus 67 is going to be 0. And then 70 minus 67 is going to be 3. Okay, so for part A, we could answer this relatively well, and we can say that if you take the temperature, Fahrenheit, minus 67, that will equal the number of sunscreen bottles sold. Okay. So done. That was pretty nice, right? Next, B, find an equation that relates the temperature to the units of ice cream sold. Okay. Now, if we look at temperature and units of ice cream, 72 and 36 looks like you're dividing by 2. But 73 and 49, that doesn't quite work. 67 and 1, 70 and 16. That pattern, I think, is a little bit more difficult for us to figure out. Okay. So let us go back to that problem. Okay. So let us go back to part B in a little bit. Onwards to part C, and let's see what we can extract here. Find an equation that relates the number of sunscreen bottles to the units of ice cream sold. Okay, so here if we look at the remaining 2 columns, S and I, 5 and 36, 6 and 49, 0 and 1, 3 and 16. Well, one thing that we can point out here is that the units of ice cream, these are all perfect squares, right? 36 is really 6 squared. Man, why is my pen leaking? Let's try that one more time. 36 here is really 6 squared. 49 is 7 squared. 1 squared. Right? And 16 is 4 squared. All right, so again, this is really 1 squared. This is 4 squared. So you can kind of see the pattern that if we add 5 plus 1 we get 6, 6 plus 1 we get 7, 0 plus 1 we get 1, 3 plus 1 we get 4, and we square all of those, we get the units of ice cream. So we can say that if we take the units of sunscreens and we add 1 to it, and then we square that answer, that will give us the number of ice cream, or the units of ice cream that we've sold. Okay, and we'll go back to part B in a little bit, but you can see that from these 2 equations, it is sufficient for me to do a little bit of substitution and figure out the equation for B. Okay, so B by itself here is a little bit challenging, but we'll get to that in the next video. So I just want to set this up. First part here, we haven't done anything with parametrics yet. We've just done a little bit of pattern recognition to figure out the relationship between two variables. The next couple videos, we'll look at how all three of these are related to each other. As always, thank you for watching. Be sure to watch the rest of the videos and have a wonderful day.